13.8 billion years ago, everything you have ever seen was packed into a space smaller than a single atom. Every star, every galaxy, the ground beneath your feet, all of it unimaginably hot, unimaginably dense. And then it began to expand. We call that beginning the Big Bang, but almost the moment you grasp it, one question arrives and it refuses to leave. What happened before? What came first? Tonight we chase that question all the way to the edge of what physics can actually say. And I have to warn you now, the honest answer may be stranger than any story we could invent. But first we have to clear away a myth. The Big Bang was not an explosion. There was no bomb going off in the middle of empty space. If you picture that, you have already gone wrong. It was not something that happened in space. It was space itself beginning to stretch. There was no outside, no edge, no dark room waiting to be filled. Every point in the universe was rushing away from every other point all at once. So when we say the universe was smaller, we do not mean it sat in a corner somewhere. We mean the whole of it, everywhere that exists, was closer together. Hold on to that. It quietly changes the entire question. Now this is not a guess. It is one of the best tested ideas in all of science. Point the right instrument at the sky, and you can still see the heat of that early universe. It is called the cosmic microwave background, the oldest light there is. It was set free about 380,000 years after the beginning, the moment the cooling cosmos first turned transparent. That light has been traveling ever since. Today it has chilled to just under 3 degrees above absolute zero, and it rains down on us from every direction. NASA satellites have mapped the whole sky of it. It is, quite literally, a baby photograph of the universe, and it fits the expanding picture almost perfectly. So we can do something remarkable. We can run the film backwards. The galaxies are flying apart, which means yesterday they were closer, and the day before closer still. Wind that back far enough and everything crowds together. The universe grows smaller and denser and hotter. Push further and atoms themselves shatter into raw particles. Further still, and even those dissolve. Every step of that story, from the first few minutes onward, matches what we measure, the exact amount of hydrogen and helium, the glow of that ancient light. The established science carries us astonishingly close to time zero, but close is not the same as all the way, and it is that final sliver that breaks everything wide open. So what about that first sliver of a second? Here the leading idea is called cosmic inflation. It was proposed by the physicist Alan Guth in the early 1980s, and it suggests that in the tiniest fraction of an instant, the infant universe ballooned. It expanded faster than anything before or since, doubling in size again and again in less time than light takes to cross an atom. Inflation would explain why our universe looks so smooth and so flat on the largest scales. It is our best model of the first moment, but let me be careful with my words. Inflation is strongly supported, not yet nailed down. We are still hunting for its final fingerprint. Keep that line clear. Established science versus leading idea. And here is where things turn truly strange. Take our finest theory of space and time, Einstein's general relativity, and wind the clock all the way back to the very start. The equations do not hand you a tidy beginning. They hand you a singularity, a point where the temperature, the density, the curvature of space all rocket toward infinity. And infinity, to a physicist, is not an answer. It is an alarm. It means the theory has hit its limit and stopped making sense. So at the one moment we most want to understand, the beginning itself, our best equations break down. To go further, we would need a deeper theory that we simply do not yet have. Which brings us to the deepest twist of all, and it is not about a missing measurement. It may be about the question itself. In classical relativity, time is not a fixed stage on which the universe plays out. Time is part of the universe. It is woven into the very same fabric as space, and if that fabric begins at the Big Bang, then time begins there too. Stephen Hawking captured it with a single, haunting image. Asking what came before the Big Bang, he said, maybe like asking what lies north of the North Pole. There is no such place, not because it is hidden from us, but because the words themselves stop meaning anything. The question may have no before to point at. But and this matters, that is not the end of the story, because maybe time does not begin at the Big Bang. Maybe our theory is simply incomplete, and so physicists have built other ideas, honest attempts to reach past the wall. Now I have to label every one of these clearly. They are hypotheses, not established fact. The first is the bounce. In some models, our Big Bang was not a beginning at all. It was a rebound. a previous universe collapsed inward, squeezed to an unbearable density, and instead of crushing down to a point, it bounced and became us. In these pictures, there genuinely was a before, a whole cosmos on the far side of the crunch, but we cannot yet see through to check. The second idea is wilder still. Remember inflation, that runaway expansion at the start? Some versions suggest it never fully switches off. In this hypothesis, called eternal inflation, the expansion keeps roaring on forever across a vast background, and every so often in one small patch it stops, and that patch settles down into a universe like ours, a bubble. If that is right, then our entire cosmos is just one bubble among countless others, still endlessly forming. In a sea that never had a beginning, this is the multiverse, and notice what it does to our question. There would be no single before the Big Bang, only our bang, one of an endless many. Let me say it plainly, this is speculation at the frontier, fascinating, unproven, perhaps untestable. And there are more. Roger Penrose, a Nobel laureate, proposed something he calls conformal cyclic cosmology. In his picture, the universe passes through endless ages he names Aeons, each one ending in a cold, empty eternity that somehow becomes the hot beginning of the next. Then there is a very different answer from Hawking himself with James Hartle. Rather than a sharp edge, they imagine time curving gently into space near the beginning. In their picture, the universe has no boundary and no true first moment at all, smooth and self-contained. I want to be honest about all of these. Not one of them is confirmed. They are rival attempts to think the unthinkable, and right now, we cannot say which, if any, is correct. So why can't we simply look and settle it? Because the universe hides its own birth. Remember that oldest light, the cosmic microwave background? It is a wall. For the first few 100,000 years, the cosmos was an opaque fog and no light escaped it. We cannot see with light beyond that curtain. Everything earlier, inflation, the first instant, whatever might have come before, sits behind it. We chase it with faint ripples in gravity, with particle physics, with mathematics pushed to its breaking point. But it is possible, genuinely possible, that the answer lies permanently out of our reach, that the beginning keeps its secret, and a scientist has to be brave enough to say the three hardest words, we don't know. So here is where we honestly stand. We know the universe expanded from a hot, dense state 13.8 billion years ago. That much is rock solid. We have a strong leading idea for its very first instant, but the question of a before splinters into wonders we cannot yet choose between. A bounce, a bubble, an endless chain of eons, or a beginning where time itself simply starts and before means nothing at all. Maybe one day we reach past the wall. Maybe the question dissolves in our hands. Either way, I think that is the honest kind of awe, so I'll hand it to you. Do you think our universe had a before, or did time itself begin at the bang? Tell me why in the comments, and I'll see you in the deep field.